Hello, everyone. I think it's the first time somebody's talking about functional programming in a cinema. I'm really excited about that. I hope you are too. So, how many of you have heard anything at all about functional programming? That's a lot of hands. That's great. Not so long ago, functional programming was regarded as some black magic. It wasn't very popular. It was regarded as something very difficult to learn, very complex, and not really practical. It was used at universities, but not in real-world companies, not for enterprise applications. And people even made some jokes about functional programming. By the way, Haskell is the true original functional programming language. And if you don't get the joke, you will after the end of my presentation. But this is changing. And it's changing partially because of JavaScript. So functional programming is getting more and more popular. It's getting traction. And as I said, it's in part because of JavaScript. JavaScript has a lot of functional programming elements in it, a lot of functional programming concepts. What's more, there are new frameworks and libraries, such as NGRX, which Todd talked about, that are very much invested into functional programming, and they borrow a lot of ideas from that world. However, Angular, by design, it's not very much inspired by functional programming. However, I would like to show you some ways of using functional programming in Angular. I'd like to show you some examples that will hopefully make you interested in that topic. And I will try to show you that functional programming can help you write better code and build better applications. And a lot of functional programming presentations start with some dry definitions of what functional programming is, and by enumerating all these abstract concepts such as pure functions or monads or whatever. And I don't want to do this. I don't want to discourage you, to frighten you. I would much prefer to show you some practical real-world examples, and I will try to explain the concepts on the way. All right, let's start with the first example. So we are building a very typical Angular application, and we want to fetch some data from the backend, some list, and display it. So let's say we are fetching a list of blog posts. And if you have AngularJS and there is one more requirement. We only want to show posts with titles that are longer than 50 characters. If you have AngularJS background, then you would use a filter here. In the new Angular, we have pipes, but we don't have a pipe available that could do this filtering for us. So what we can do is either write a custom pipe or just filter out the posts with short titles in our component after we receive the result. So here is some example of the code that could do that. And it's pretty simple. So we create a new array, an empty array, in which we will store posts with long titles. Then we iterate over this array. And for each post, we check whether the title is longer than 50 characters. And if it is, then we push the post to our array with results. And this code is okay, but I don't really like it. I think there's a couple of wrong things with this code. First of all, it's quite verbose. It has a few lines. We just want to do a simple thing. We just want to have posts with long titles, right? And we are also introducing some new variables here and assigning stuff to them, mutating them. So my point is that this code doesn't capture the intention of the programmer very well. If you come and look at this code, you have to spend a while thinking about what it does. It's not obvious. So can we do better? Of course we can. With functional programming, the same functionality can be implemented with just a single line. I think it's pretty cool. So what's happening here is that we call a native array method called filter. And we pass to it another function. This function, the fancy name for it is a predicate, will be evaluated on every single item of the array. And depending on the value it returns, it should either return true or false. If it returns true, then the item will stay in the resulting array. And if it returns false, it will be dropped out of the array. So let's visualize it. We have the array with posts, and first we call our predicate function on the first element. It returns true, so the post stays. But on the second element, it returns false, so the post is dropped out, and so on, and so on. So the first functional concept I wanted to show you is called higher order functions. And higher order functions are simply functions that take other functions as an argument. And this is exactly the case in our filter example. And higher order functions are especially useful in context of array operations. So in JavaScript, we have some built-in higher order functions on arrays. We have filter, which I talked about. We have reduce, and we have map. And also we have others. So, as you saw, higher order functions can help you write less verbose code that's more difficult to break, and most importantly, code that captures the intention of the programmer very well. Because if you look at this filter example, it's almost like natural language. You just look at the single line and you immediately know what it does. And finally, there is one more advantage. Writing code in such way, writing array operations in such way, is just more fun. I remember this situation at work when some of my colleagues were doing a lot of array operations in a traditional imperative way, and it was very complex, large piece of code. So he came to me and we sat down for some time, and we managed to refactor this code to just a few chained method calls of higher order functions. And it was a lot of fun. It felt like putting pieces of puzzle together. So I think it's really worth looking into, if not for all the other advantages I mentioned. Cool. Let's jump to the next example. Again, we are fetching some data from the server side. And this time we are fetching a list of comments. So let's say we can either fetch good comments or bad comments. And as you know, with the new Angular, we have this HTTP client API, which has a get method, which we can use to fetch some data from the server. But this get method, it returns an observable, not a promise like it used to with AngularJS. However, we can just forget about this fact and treat this observable in a similar way that we treat the promise. So we can just subscribe to it, and the data we received, we will assign it to a field on our component. And this is perfectly all right, But what happens if you want to also allow fetching but comments? So we just add another button and another event binding and another handler in which we do exactly the same. And we again assign it, the result, to the comments field of our component. So imagine having like 15 such interactions in a single component. It can get quite messy, right? And especially if there are multiple developers working on this component and they just keep adding different assignments to the comments field in different places. At some point, we may realize that our component is no longer predictable. So we can't easily reason about what is at a given time inside the comments field. And I think you agree that it's not a good thing, right? It would be nice to be able, by looking at the code, to be able to reason and to predict what's in which field when. So what is another approach to do this? Another approach is to change our thinking. Instead of having buttons and event bindings on them, we think of our button clicks as streams. So every time someone clicks on a button, an observable will emit a value. So that's what we do here. We introduce the comment stream observable. But then, for every value triggered by this click stream, emitted by this click stream, we want to go to the server and fetch some data. So we again can use the HTTP GET method, which gives us an observable. So now we have an observable that emits observables. We can use the merge map operator from RxJS to squash it into a single observable. It's a bit of technical details, but the idea is that we end up with the good comments clickstream observable, which will emit an array of comments every time somebody clicks on a button, and the server replies with the response. So now we can bind to this observable in our template using the async pipe from Angular. So actually I've made all this code just more complicated, added a lot of boilerplate. So how is it better than the previous approach? It shows when we keep adding more and more interactions and more complexity to the component. Because now imagine we also want to be able to fetch but comments. So we add another click stream for another button, and again we go to the server, do merge map or switch map. And at the end, we have to merge these two observables. So we have a single assignment to the comments stream. We create the observable that represents the data that will be in the template in a single place. So now we can't have another developer come in and just drop some code somewhere in the middle of our component and assign to the comments field. They would have to somehow touch this single central place. They will have to somehow compose their observable with our observable. So now we have eliminated the state from our component. And what's more important, we eliminated state mutations. And if component doesn't have this mutable state, it's much easier to reason about it. It's much easier to find bugs. And it's basically more predictable. So the concept I demonstrated in this example is called pure functions. Because the problem with the first approach was that we had impure functions in our code. We had functions that had side effects. They manipulated something that wasn't owned by them. So in our case, it was simple. They were just assigning something to a field on the component. And pure functions are functions that don't do such things. Their output is only dependent on their inputs. And in the second example, with merging observables and everything, we only have pure functions. So that's the important thing about this example. Try not to use impure functions. Of course, I'm not saying do this in every single component, because for simple components, it's perfectly all right to do this the simple traditional way. It may not be worth it to introduce all this boilerplate. But if you have a complex component with lots of interactions going on, then give it a try. All right, now the third example. And I think that's the most interesting one, so I really need your attention here. And Boromir can give you some clue of what it will be about. But before, let's stop for a while and let's ask ourselves, why do we like Angular so much? I think one of the reasons is the fact that we don't need to manipulate the DOM model directly. You don't need to touch HTML. We can make changes to our data model, and changes to data model will be reflected in the view automatically. And the mechanism responsible for that is called change detection. As Nir actually talked a bit about it, but I will talk about it in a more functional context. So let's see how change detection works. As we know, an Angular application is a tree of components. So we have one big component which has some nested components, and they have nested components, and so on. And for every component, there is a change detector associated with the component. So if some event happens somewhere in our application, Angular runs every single change detector. And what these change detectors do is they simply compare the values from before the event and after the event. So obviously, if the values are not equal, then there was a change, and the view needs to be updated. But does really Angular have to run change detection for all the components? Let's take a look at this example. We have a simple book details component, and inside of it we have author details component. And we use property binding to pass the author object to the author details component. So now how could change detection work? If I knew that author value wasn't changed, then maybe I don't need to run change detection for the nested component, right? Because no change to author, so why waste time on change detection for author details? Unfortunately, this could happen. So we can have a method that modifies something inside the author object. And because of that, Angular can't make any assumptions, and it has to run change detection for the nested component, because it won't analyze the code of our components and won't be able to detect that we are manipulating the internals of the object we are passing in property binding. However, we can help Angular in that regard. We can help it be smarter about this. And the way to do this is to change the change detection strategy on our component. The default, we are changing it from the default one to the on-push change detection strategy. But this requires us to have some new rule when writing our code. We have to write our code in a slightly different way. So the rule says that we can't modify properties of our objects. So what kind of ridiculous rule is it? Like, why? How can I program with such a stupid rule? It's actually quite simple. Instead of modifying a field inside an object, you just create a new copy of the object with the updated property. And that's it. So that's what we do in the new implementation of the change name method. And now, what does the on-push change detection strategy do? Now that we have this assumption that an object, the field inside an object will never be changed, the on-push change detection strategy says that change detection for the nested component will only be triggered if the reference passed in the property binding is changed. So it fits very well, because the only case the reference to author will change is if something inside the author object is changed. And if we didn't have such a rule, then we could modify the internals of author, and change detection for the author details component won't be run. So the change will not be reflected on our view. Therefore, we need such a rule. So now, change detection will only be triggered for components that are interested in this change. If we set the new on-push change detection strategy on every component, and if we stick to this new rule. And what is this new rule? It's exactly something that is called immutability in the world of functional programming. So, just to rephrase, instead of, we must not modify properties inside objects. Instead, we create new objects with updated properties. And you saw the advantage of this. Like in Angular application, having such rule can help Angular be smarter about change detection. But in general, immutability, while it makes writing code maybe less intuitive and more complex, it can let you have more assumptions about your code. So you can then write simpler code and make less bugs in this code, and also have some performance optimizations, as it's happening in this case, in this example. So that's the main benefit of immutability. All right. These three examples I showed, they were all based on pure Angular with pure JavaScript. No external libraries involved. Or maybe RxJS, but it's part of Angular. But there are some interesting libraries that can help you get the idea of functional programming even further. So there is lodash, which was already mentioned during this conference. And it's interesting in the context of higher order functions, and especially array operations. Because in pure vanilla JavaScript, we just have a few of these array operations. But lodash introduces a whole arsenal of them. And you can do really crazy stuff with all these array operations. And it can make your code better, easier to understand, more readable. Then we have Redux, which Todd explained in great detail. But in general, it's just another approach to having a predictable state. So the problem I talked about in the second example. Redux is even more functional approach than the one that I showed to this problem. And it's really interesting. Third, RxJS. It's functional in a sense that it can help you eliminate mutable state. But it's also functional in another aspect. It has a lots of operators that are actually higher order functions. And they are also similar to operations on arrays. So once you understand all these higher order functions on arrays, it's also easier to grasp Redux.js. And finally, with regards to the third example, I talked about immutability, but JavaScript itself obviously is mutable. Objects are mutable. So enforcing immutability might not be easy, right? It's difficult to prevent all developers from modifying objects. But there is a library called Immutable.js, which can help you enforce immutability in your application. And it also does it in a very performant way. So that when you do a lot of cloning of big data structures, it doesn't clone the whole structure. It uses a technique called structural sharing, which makes it much more performant. Cool. To wrap it up, let me enumerate the three main takeaways from this presentation. So firstly, use functional array operations. I don't really see a reason to write array operations in an imperative way. It's almost always non-optimal. Your code is more verbose, and it's easier to make a bug. Then consider avoiding state mutations. As I said, not in simple components, not in CRUD applications. But if you have a lot of interactions going on, and if you have a really complex component, then give it a thought. Maybe it's the right choice. Finally, if you are experiencing performance issues with your Angular application, consider introducing immutability. And then it will allow you to make some assumptions about your code. And specifically, it will allow you to use the on-push change detection strategy. So I hope I convinced you that functional programming is worth looking into. And by doing this presentation, I wanted to inspire you to give it more thought and to familiarize yourself with more concepts. And I wanted to show you some real-world Angular examples as an entry point to the world of functional programming. Because I really believe that functional programming can make your code better and can make you better developers. So remember, the functional way is the right way. If anybody wants to ask me a question, I will gladly answer. Please contact me at any of these. Thank you very much.